What if Earth's biggest ocean isn't on the surface, but hidden deep beneath our feet?
If you look at the surface of our world, the sheer volume of water you see is truly overwhelming. For centuries, geologists operated on a straightforward assumption that all this liquid is strictly a surface feature. In this model, Earth is essentially a dry, solid ball of rock, wrapped in a very thin, wet shell. Because that thin layer is where we live, we define our entire planetary identity around it. We are the blue planet because of the accessible, visible water we can actually touch and see. In 2014, researchers analyzed a microscopic flaw in a diamond pushed up from the deep Earth and found clear evidence of water trapped inside. That specific diamond originated nearly 700 kilometers straight down, pointing directly to a massive water source locked deep inside the Earth's mantle. This animated diagram compares the volume of all our known surface oceans against the estimates for this subterranean reservoir. The deep mantle may hold as much water as every ocean, sea, and river on the surface combined, and potentially up to 3 times more. Yet, if you were to somehow travel down to this reservoir, you wouldn't find a single drop of liquid. There are no underground caverns, no waves, and no hidden seas. At 700 kilometers below the crust, the laws of physics make the existence of liquid water entirely impossible. To understand how an ocean can exist without liquid, we have to look at the extreme environment down there. Leaving the familiar oceans behind, a vertical drop into the planet requires passing through environments entirely hostile to life and to liquid. You push past the thin outer crust, a mere 30 or so kilometers deep, and enter the thick, dense rock of the mantle layer. By the time you reach the 700-kilometer mark, the ambient temperature exceeds 1,500 degrees Celsius. It is an inferno hot enough to easily melt standard surface rock. Simultaneously, the weight of the 700 kilometers of stone above creates crushing pressure. Down here, the atmospheric pressure is hundreds of thousands of times greater than at sea level. Any liquid water would instantly vaporize from the heat, and any vapor is immediately crushed by the weight. You are left with a highly pressurized, completely solid rock matrix. This brutal environment serves as the vault for the Earth's largest hidden ocean. The only way water survives here is inside a rare, high-pressure mineral called ringwoodite. To see how rock can hold an ocean, we have to scale down from the macro weight of the mantle and look directly at the atomic mechanics of this specific mineral. This 3D molecular lattice illustrates ringwoodite's structure. Under immense pressure, its geometric framework maintains empty spatial gaps, acting as a geological sponge. When water is drawn down, it's dismantled into hydroxide ions that flow into these gaps, locking directly into the solid architecture. The intense heat and pressure of the mantle actually force the crystal to bind with these ions. The water ceases to be a liquid and becomes a permanent structural component of the rock itself. The largest reservoir on the planet hides entirely out of sight because it is stored atom by atom, perfectly disguised as solid stone. Zooming back out from the microscopic lattice to the scale of the entire globe reveals a massive continuous layer of this waterlogged ringwoodite wrapping around the Earth's interior. This band of hydrated rock operates in constant motion, functioning as a highly active plumbing system for the entire planet. This cross-section shows the mechanics at work. When tectonic plates shift and push surface crust down into the mantle, the temperature and pressure changes force the deep ringwoodite to sweat out its trapped water. That upward release of water lowers the melting point of the surrounding rock, which triggers magma to form and eventually powers surface volcanoes. Over billions of years, this deep internal water cycle has regulated the movement of the continents and the steady venting of the planet's internal heat. The ringwoodite reservoir operates as a vital geologic engine, keeping the Earth's surface active and ultimately capable of supporting life. When we look back at the surface, our understanding of the blue planet looks completely different. The crashing waves and vast surface oceans we cherish are merely a thin layer of leakage, the visible byproducts of a much larger water cycle churning deep underground. The greatest ocean on Earth operates in total darkness. It is the very rock beneath our feet.
Earth still hides incredible secrets, and this hidden ocean is just one of them.